Hello, welcome to Cerp TV. When it comes to vectors, normally we have two types of products. Number one is what we call the dot product. The second one is what we call the vector product. Another name for dot product is the scalar product. And then we have the vector product or the cross product. So we have a problem here that says if A is equal to 3i minus 2j plus k and B is equal to I plus 3j plus k, find number one A dot B and number two A cross B. Now A dot B is very simple to do. You simply multiply corresponding coefficients and then add them up. So it simply becomes the coefficient of I here is 3 and the coefficient of I here is 1. Then plus the coefficient of J here is minus 2 and the coefficient of J here is 3. Then we add up. The coefficient of K is 7 and the coefficient of K here is simply 3. Then when you add up, you simply get that 3 times 1 is going to give me 3, minus 2 times 3 is minus 6, 7 times 3 is 21. So at the end of the day, 3 minus 6 is minus 3, minus 3 plus 21 simply gives me 18. So that is the dot product of that vector. Now we come over to the second one, which might involve a little bit of calculation. Now, if we were asked to find a cross product, all what I am simply going to do is to say that A cross B, I will convert the given vector into a matrix, a 3 by 3 matrix, and evaluate its determinant. Now, how do I do this? A cross B, I'm simply going to have the determinant I, J, K. Beautiful. The coefficient of I here is 3, coefficient of J minus 2, coefficient of K is 7. Now the coefficient of B of I here is 1, coefficient of J is 3, coefficient of K is 3. So we are evaluating this determinant. We are going to convert. Now to find the determinant of a 3 by 3 matrix, all what you need to do is to convert to 2 by 2. So this simply becomes I'll delete the row and the column that involves that particular element. Now when I do that, I will have minus 2. I'm deleting here and here. This is I, so I'm deleting its row and column. So I have minus 2, 7, 3, 3. And then I have, when it comes to the second term, I'm going to use a minus. So we have minus, I'm deleting minus J. What is left? I'm deleting here and here. I have 3, 7, 1, 3. And then let's look at what we have for K. Now when it comes to K, this is K. So I'll simply have 3 minus 2. 3 minus 2, 1, 3. So we are going to evaluate this. So let's quickly clean up so we can have some space to find the determinant of that given determinant equation. So you discover that A cross B simply become equal to, I'm going to have I open a bracket. To find the determinant of a 2 by 2 matrix, simply multiply this way, minus the other diagonal. Now when you do that, 3 times minus 2 is minus 6. So I have minus 6, minus 3 times 7 is 21. I close. Then we have minus J. When I have minus J, 3 times 3 is 9. So I have my 9 here. 1 times 7. 1 times 7 is 7, minus 7, and I close. Then I have K. I open a bracket. 3 times 3 is 9. So I have my 9, minus 1 times minus 2 is minus 2. So I simply put a minus 2 here to distinguish it from that other minus. Now let's quickly evaluate. This simply becomes, we have I, minus 6 minus 21 is minus 27. We close that bracket. 9 minus 7 is simply going to give me 2. So I simply have minus 2J. Then I have plus, I now have K into 9 minus minus 2, minus and minus will change to plus. So what do I have? I simply have 9 plus 2, which gives me 11. So at the end of the day, my answer simply becomes minus 27I for this one, minus 2J, then plus 11K. So that gives us the cross product of that vector, those two vectors. So you notice that to find the cross product, you get a vector. Meanwhile, to get the dot product, you simply come out with a number. Thank you so much for tuning in. Please do well to subscribe to Cerp TV. Bye-bye.